we have to determine these values and put them in the correct ascending order. So one value is 0. So I'm just going to write 0. Okay. The other value is g prime of -2. As you see, -2 is here. We're asked, so this is g of x. We're asked to find the rate of change, the instantaneous rate of change of function g at -2. That is given by the slope of the tangent line to the graph of g at -2. Okay, so here is -2. I know you cannot really see perfectly. Okay, so I'm going to draw I'm going to draw the tangent line, and I will have to estimate. I think it's not 1/1. I think it's maybe 1.5/1, or maybe even 2/1. So I'm going to say that this g prime of -2 is roughly, it's positive, is roughly +2/1, so approximately 2. Back
to... Do you measure if it's positive or negative based on the corner?
Very good question. Very good question. Okay. So we have lines in general. We have a line that is increasing from left to right, and this line has a slope that is positive. Another possibility, we have a horizontal line. By definition, the slope is 0. Another line is when it's decreasing from left to right, and this line has to have a negative slope. And we have the last one, last possibility, where the slope is undefined. That's why here the derivative does not exist, because I don't have a slope. Here the derivative exists because I have a slope. Here the derivative exists because the slope is 0. Here the derivative exists, let's say here, because I can tell you it's negative. I can approximate it. I cannot be able to, if you don't give me the function, I cannot tell you exactly what it is. But I can tell you exactly for sure, if the tangent is vertical, that number does not exist. That's why the function is not differentiable if it has a vertical tangent. Is that okay?
Okay, so what about the dotted lines?
You're talking about these?
Yeah, like, how come that's +2 and 1, not -2 or -1?
Does it look like this?
Not the slope. I understand if it's going up, then positive slope. But I'm talking about the opposite and adjacent part of the triangle.
Okay. So let's say I have these 2 points. I'm asked to find the slope of the line passing through them. Point A, point B, I want to find the slope going, the slope of the line passing through these 2 points. How do I determine the rise? How do I determine the run? Does it matter where I determine the rise and the run? Does it matter? As long as this is the same distance, of course. So this is the rise, this is the run. So this is the rise, and this is the run. You can extend it as long as you want, if that's what you want to do. Still. So it's, to me, it appears as 2/1. This appears.
So will the numbers always be positive?
If it's this way.
Okay, so if the slope is positive, the other sides are also positive.
The numbers are always positive.
That's what I was asking.
The numbers are always positive, right? So this is a distance. So the distance is 2. This is a distance. For me, the distance is 4. But I know that the slope has to be negative. It's rise over run. No number is negative. It's a distance. The distance between these 2 points is 2. The distance between these 2 points is 4. But I know for sure that this has to be a negative slope. You could consider y2 minus y1 over x2 minus x1 as the formula. And then you will get the negative number. If that's what you want. You're just using the definition. But these are distances, right? So they have to be positive. But since this is the line that has a negative slope, the answer has to be negative. Or you say y2 minus y1 over, so this is y1, y2, so this is, I didn't mean that. I meant to put it here. So x1, y1, and x2, y2. So y2 minus y1 over x2 minus x1. So the denominator will be negative because you're doing x2 minus x1. But you don't even have to think in those terms. These are distances, but this is a slope that has to be negative. Is that clear now?
Yes.
Perfect. So we're back here. So we finished with these first two. We didn't have to do anything to 0. Now g prime of 0. Okay, so g prime of 0 is, so I have to draw a tangent here. Obviously, g prime will be a negative number at 0. So back to my graph. So this is, and I attempt to say that this is kind of -1. They appear, well, of course, as I mentioned here, positive, but it has to be negative. So I will say that g prime of 0 is -1. It has to be negative. Then, so this is done. Now g prime of 2. So let's take a look at g prime of 2. G prime of 2, again, is pretty much like here, but it is less steep. So look here, this is the slope, this is the tangent, but here is it's less acute. So this number has to be higher than this number, for sure. Okay, so then when I draw a horizontal tangent. You know what I mean. A positive slope, of course. And I am tempted to say that this is roughly probably 1 over 1. Definitely has to be smaller than this one. Look at the two tangents. This is like this, and this is like this. Obviously, this is more steep than this. So I will say that g prime of 2 is 1. Okay, last one. What was it? I have it here, but you cannot see it. They're asking us for g prime of 4. So at 4, it's positive, but definitely smaller than this, and definitely smaller than this slope. So this is the smallest positive slope. Okay, so let's try to determine that. Yes, I know it's not easy, but this is a good exercise to understand what's happening. So if this is the case, I'm tempted to say kind of 1 over 2. So I got that g prime of 4 is 1/2. So now when I want to put them in order, I will have 0. I'm sorry. I will have -1. I will have 0. I will have 1/2. I will have 1. I will have 2. So the correct order, -1, 0, 1, 1/2, and 2. But the correct order is g prime of 0, then 0, 1 was g prime of 2, and then 1/2. Oh, well, what can I say? For me, 1 is smaller than 1/2. Okay, I have to correct that. So 1/2 here and 2 and 1 here. No, 1 is not smaller than 1/2. Okay, so 0, g prime of 4, and then g prime of 2, and g prime of -2. One more time, let me make sure. So I put in a -1, then I put 0, then this was the smallest. G prime of 2 was 1, and the last one of 2. Yes, this is correct now. Okay, so what does this exercise say to us? Well, basically, it analyzes the function. So notice that the slope here is huge, huge. Then smaller and smaller and smaller and 0. And then positive, and then negative. It turns negative. And then big negative. And then smaller negative. And smaller negative. And smaller negative and 0. And then positive. Big, and then smaller positive, and then smaller positive, and then smaller positive, and then smaller positive, and then smaller positive. Okay, so that's how we look and analyze and understand the rate of change of this function. Okay, I think that's good enough. I wanted to look at another problem. So allow me to possibly put this as page 2. Or I can put it as page 1, it doesn't matter. Okay. So find an equation of the line tangent to the graph of, so find equation of a line tangent. Oh, I'm so sorry, I forgot to ask you. Any questions? Forgive me. Any questions? Find equation of, yes, go ahead. So sorry.
I was just going to say, with that whole it's almost all approximation.
Oh, absolutely. But what is not an approximation is the order. And which one is steeper? That is not an approximation.
So it's more about putting them in the order of which slope is greatest.
Yes, what is not an approximation is that it's clear that at this point is the steepest positive. Then next in line, from the highest, the next one in line is this, and this is the smallest. It flattens. So the top high positive, the next positive, the smallest positive. And of course, there is no discussion here. This is negative. Of course, it's the smallest of all. So that is basically, yes, they're all approximations. If I had the grid, and if I were able to, the coordinate system, if I were able to draw this line through the corners of a grid, then I could have told you correctly what it is. But I don't have the grid behind it. So I can't tell you what it is. I have to approximate. But definitely, this has to be right in between these two. This is the smallest, and this is the most acute, if you want. Okay, so we want to find the equation of the tangent line to the graph of this at x equals 5 if g of 5 is -3 and g prime of 5 is 4. Let's see how we analyze this.
First, we do y minus y1 equals m, x minus x1.
Excellent. What do we know from all this? Excellent, thank you.
G prime is our slope.
We do know 4. Awesome. Great job. Thank you, Aaron. What else we know?
X1 is 5 and y1 is -3.
That's it. So there is really nothing to it. So y plus 3 equals 4x minus 5. I distribute 4x minus 20 minus 3. Good. I didn't have anything to say there. Anyone, any questions?
I'm having a hard time reading some of the writing.
Can you pin the speaker? Do you know how to pin the speaker?
No, it's pinned. It's the like. Does that say IFG right there? Next to the x equals 5, is that IFG?
If
Oh, FG. Okay.
if g of 5 is negative 3, sorry about that, and g prime of 5 is 4. Good. I want to look at the book, and then let's continue with other. So this I don't need. This I don't need. This I need. Yes? Any questions?
Yeah, so are you still planning to have our test on Tuesday or?
We'll discuss it. Allow me to finish. Very good point. Oh, yes. There was one thing that I was going to mention. So I promise I will not forget to discuss this when we finish. Allow me to finish, and then we'll start reviewing and we'll talk about it. Yes, we'll decide together. So one of your colleagues asked the following question. When do I rationalize the denominator numerator when finding a limit? This was a brilliant question, and I want to address it. So the answer depends. In algebra, we say that the denominator has to be rationalized. We all know that. Now here, I don't have a clear answer. Here's why. Because it depends on the function. If the numerator creates the problem, then I rationalize the numerator. If the denominator creates the problem, if the denominator is the culprit, then I will rationalize the denominator.